All right, so starting off with Thermodynamics 23. This one was from the TFS program, but it certainly applies to both disciplines. So I did this problem incorrectly because I assumed H sub 3 equals H sub 1 plus H sub 2. I was supposed to find H sub 3 from the saturated water and steam tables. Why can't I assume H sub 3 equals H sub 1 plus H sub 2 is true when the mass balance equation M3 equals M1 plus M2 is true? So just for context, this one was about an open feed water heater. So we had coming in water, liquid water was state one, and then steam was state two. And we had a little bit more information than that, but just to give some context. And then the leaving condition we knew was going to be a saturated liquid or a saturated mixture, right? So we don't really know if it's going to be a mixture of liquid and steam, but we know it's going to be a saturated condition. So I'll put saturated liquid. And the question dealt with the mass balance and the energy balance. And we had to use both equations together. So when we write the conservation of mass equation, we're saying that M1 or M dot 1, because it's a mass flow rate, plus M dot 2 equals M dot 3. Nothing groundbreaking or earth-shattering there, right? That's the idea of the conservation of mass. We have two streams coming in and one stream going out. So I don't think there was any confusion with that being true. The question comes in when we're ready to write the conservation of energy piece, which was critical to this one. On the conservation of energy piece, we have to say that the same is true for the enthalpy, but when we do that, we have to make sure we write big H, H1 plus H2 equals H3. And I probably didn't write this in my solution. I probably jumped right to the next thing, which is expanding on that idea. And where does that come from? So remember the distinction, we covered this in the fundamentals pretty early on. It's probably one of the first 10 lessons, the distinction between intrinsic and extrinsic properties. So an intrinsic property is per unit mass. An extrinsic property is just the total amount. So the total enthalpy, extrinsic, is big H, and the intrinsic, specific enthalpy is little h. So what is the definition of little h? Little h is big H per unit mass. Or to rearrange that, we want to get big H by itself. It's mass times the specific enthalpy, little h. So if we make that substitution for each part, we can say m dot 1, and I'm going to take the liberty of going from just mass, to a mass flow rate. So I'm going to put the dot, this would all still be true if we had dot, 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 dot. So we can say m dot 1 little h1 plus m dot 2 little h2 equals m dot 3 little h3. So this is the mass balance, and this is the energy balance. If instead you were to say H1 plus H2 equals H3, that doesn't really make any sense because you can't add intrinsic properties that way. They're not additive. It's like if I had, it's like if I were mixing two beers together, right? Like imagine I have Bud Light with 4% alcohol, and I have some Canadian ice beer, which is 10% alcohol by volume, and I pour them together. Do I have 14% alcohol in that mixture? No, of course I don't. I have something that's between 4 and 10, and where exactly it lands, if they're equal volume, then maybe it's halfway in between, but it's not going to be additive. So that's why we can't add things with intrinsic properties, but we certainly can add things with extrinsic properties. So even though I didn't do it in the solution, if you were to start from here and use that idea to get to there, hopefully that makes sense. In my solution, I probably jumped straight to this because if you do enough of these, you'll probably be ready to do that as well. But I certainly would not approve of writing this. And that's the difference between the units here would be BTUs, and the units here would be BTU per pound. All right. Any other questions on that?